Thank you for having me. First of all, I introduce myself because I think almost nobody knows me in this user group. I'm normally at home in a PowerShell user group here in Hanover and in around Germany, a few other PowerShell user groups. But one of my passion is also playing around with IoT, with a Raspberry Pi, with ESP32 and this stuff, Arduino and so on. And at the beginning of this year, I had an idea if it would be possible to create a Stream Deck-like device made from a touch screen. And after Googling and searching around the internet, I hadn't found something that would fit my needs. So I started such a gadget. And what you can see here is just an AI-generated image, which looks really cool, but the device I will present you a bit later isn't as cool as this, but it's a first step, and maybe in the next months it will become a bit cooler than it is now. But right now it works. So my nickname in the internet at GitHub or X and so on is Flittermillind. So you can find my GitHub repo there. The topic I show you today is not as a GitHub repository available. I will publish it in the next few weeks, so it will become there. So just a moment. So I have a very short agenda for today. There are only 3 topics. I introduce myself a bit more as to who am I. It's a topic I'm talking about, the hardware, and a bit of the software. And finally, we come to the demo because this is the most interesting part. My name is Frank Lindenblatt from Hanover in Lower Saxony in Germany. I work in the IT since 1984 when I was a pupil, and since 1988 I was paid for what I do in the IT with various computing systems, starting with a C64 and Apple. I worked on the mainframe with OS/2, Windows, and Linux. So right now I'm in a Windows shop, so I work most with PowerShell and C#.NET. My current role is a senior DevOps engineer in the Finanzinformatik. It's a computing center of the German 7 banks. So if some of you or ever comes to Germany and want to have cash from an ATM, these transactions walk through our computing systems. My email, if you want to reach out via email, my X and GitHub account I told you, and my IT passion is PowerShell outside the mainstream. And so what I talk about today is a bit of PowerShell, but the main stuff is the IoT device, which works with Micropython. I come to it later. The topic I'm talking about is a so-called Crow panel, a 7-inch human-machine interface touch screen powered by an ESP32S3, which I hoped can act as a human input device, such as a keyboard or a mouse or something like this. But unfortunately, it turned out that this device does not support this feature. This is a picture of the device from the internet. It's 7-inch sized, and this is a website I publish these slides later, so you don't have to remember the URL, or you can take a snapshot of the QR code. So now we go to the demo. First of all, I show you the device, try to show you the device via my second camera. I hope this works. So can you see this little gadget? This is the device. This is a sandwich style device made of plexiglass or acrylic. This is the back side. So a few connectors. It has a USB-C port, and I hope you can see it. You can see it's only a UART. So if I had looked first of all when I bought this device, I may have noticed that this wouldn't work as a human input device. So it's only a serial connector. But I took this as a challenge, and so everything I made now works over the serial port. And ta-da, this is what it looks like right now. Yes, these this user interface I've made is fully controlled from the PC right now with the PowerShell script. My goal was to find a solution for some scripting stuff that I can control from an external device. So, for example, when I work with an environment with 3 screens, and I made some presentations or work with something in video conferences or so, I often want to take screenshots from the screen I currently have a web session on. And I've experimented with some tools where I can control with a single mouse click or a single keyboard click to a screenshot exactly the one screen, and not, as you know, with a snipping tool. When you press the print screen button on a Windows device, snipping tool opens in the newer systems under Windows 11, and you have to mark the area you want to screenshot with the mouse. This often takes too long, and the next slide in a video presentation is gone. So I thought, isn't it possible to have a mouse click for screen 1, screen 2, screen 3? And I couldn't find a suitable solution. So this was the first a trigger which I had, and I asked myself, can I design something? And so the first idea I had was an external screen which can act as a human input device, which I can exactly do this. And after this idea was born, I thought, well, it would be cool if there are more options I can make. And I saw the Elgato Stream Deck device. I think almost everybody knows it, have seen it, not used, but knows a few keys which you can configure with small images or text and so on. And I thought this should be possible with a touch screen. And so this is what came out. I show you how I can configure this right now. I start with the PowerShell configuration and then come later to the usability of the device. So that you can imagine what I do on the PC to show the device on the screen. I combine it. So I don't dig too deep into PowerShell, so only what's absolutely necessary. The configuration is I define a Powerdeck. In a Powerdeck, I define different layers because I don't only want to have one screen. I want to have more screens which I can configure, and these screens I call them layers. So what you can see is the first layer. If I press this button, you see the next layer called projects and another layer called desktop. And when I go back to the first layer, you can see I have defined a layer named first, and I configure a bunch of buttons because of the system I programmed on this screen works with Micropython, and Micropython with an LVGL library. It's a very cool graphics library, relative similar to Windows Forms or WPF, who always has programmed on a Windows system. There are very much similarities. So I defined a row of widgets, and each row consists of buttons in my configuration here. The buttons called unnamed print screen 1, 2, and 3. And as of now, they all start the snipping tool. So which I want to do is a screenshot for screen 1, 2, and 3. It's a future implementation this doesn't work right now, but all buttons start the snipping tool. The second row contains the buttons magic on selection clipboard and so on. And here you can see some PowerShell commands, which I've also implemented. And these functions work. So in a few minutes, I show you what happens if I press the buttons on the touch screen and what happens on the PC. So only that you have a rough idea what's going on here. Then there are a few buttons which don't have an action right now, simply to show how the layout turns out when you define a few buttons and what is presented on the touch screen. So in this case, the layer 1 consists of 5 rows with a different count of buttons in each row. The layout, which is rendered on the touch screen, is completely rendered on the touch screen. This is completely done with the LVGL UI library. Second layer called projects. It's a simple idea I had when I work on my job. I work for different projects. In my current role, I don't only work on one project. I have a bunch of 5, 6, or 7 projects right now. And sometimes I work half an hour for this project, another 40 minutes for another project. And sometimes at the end of the day, I ask myself, wow, what have I done and how long have I worked for this project? And so this afternoon, I got the idea wouldn't it be cool if I had a layer on my device where I can simply click a button and write a timestamp to a file, and at the end of the day or at the end of the week, I can simply take these timestamps, generate an Excel sheet from it, and have an exactly um, timetable what I've done in a week, on a day, or so on. And this is a simple idea I made. So I designed some buttons called named with the projects I work on, and set a function which under the hood simply writes the project name and a timestamp when I click the button to a file, and the rest I can do later. So another layout with an also 5 rows, but a different layout because the number of buttons in the rows is different than the first one. I'll show you this also later. And the last layer I have designed is a layer called desktop, where I've implemented some functionality to switch the desktop on the Windows screen to show that even if I told you that this device can't act out of the box as a human input device, with some Windows functionality, I can do keystrokes on another way, and this is something is simple where you can see something and can imagine what's possible if this project grows a bit more in the next few weeks and months. So the last layer has a different layout. So there are only 3 rows with buttons, so that you can see one widgets collection defines 2 buttons, the next 4 buttons, and the last also 2 buttons. So this is what comes out from this configuration. So, and this is the main part. When Richard called out for topics for this meetup, I only had one style of these layerings. It's a tab view with 3 tabs. So each layer I define is presented in a tab. And I thought, well, it would be cool if I can show you what's possible with the LVGL library without copying too much files from the PC to the device. So I made button in I the functionality that I wanted at the beginning was to simply this tab view. And then I thought, well, I'm a right-hander, but my display normally stands on the left side. So it is perfect when I have these buttons of the tabs on the left side. But if your desktop environment suits better when you place this device on the right side of your keyboard or on your desk, or maybe you have a split keyboard. I have a few colleagues which work with a split keyboard, so you can position this device in the middle. I thought, well, it would be cool if these layers can be selected from the right side. And so I made a function that you can flip the buttons on the right side. And this is perfect for this presentation, so that you can get a feeling what's possible with this UI library, which works under the hood. And so you can even put the buttons on the top and control the layers. And you can even place the tab view on the bottom side of the display. And you can even have a Windows style fit of the layering. And now you also need a way to flip the layers. So you can flip with these buttons back and forth through the different layers. So this is completely controlled on the device. So on the left side. That's it. Well, these styles come back, shot back to the PowerShell. I can define the tab view directions in the final state. You normally would work with one style, and this was what I first of all implemented. But as I told you, for this session, I implemented multiple styles to show what's possible. Okay. So let's come to the functions. What happens when let's start with a simple thing. Let's start with the projects. When you click these buttons, just a moment. So, the buttons. When you click the button Intune or SKI Pilot or one of the other buttons, I call a PowerShell function which is called a set project. Set project is very simple. Set project simply writes a timestamp and the project name to a file. And I have done this a few times this afternoon. I do this right now. And again here. So, and when I want to show what I have done today, I simply can show, this is what happens when I press the button show projects. Show projects. Show projects, the button. Simply opens the file, this file, in a PowerShell window. This is, sorry, this is this. And another function I put on the first desktop. So this is the function, this is the file. And when I select this file name, let me show you something. I put a text to the clipboard, and the clipboard is right now simply the TTT. Now I mark this text. I don't press any button on my keyboard. I now press the button magic on selection. And the button magic on selection opens the notepad. Because when I press the button magic on selection, this button magic on selection, what happens? Magic on selection on the first layer sends out a keystroke Control C for copy the selection to the clipboard. Then I have to wait a few milliseconds to let the operating system write the selected text to the clipboard. If I don't wait for some milliseconds, the clipboard is empty. And then I call the function magic clipboard. And the function magic clipboard is quite simple. It takes the content of the clipboard in text format, does a regx on the content, and if the regx matches letter, colon, backslash, and so on, so which means that should be a text file, it should be a path or a file, then it opens the Explorer with the file name. And this is what happens when this command is executed. It opens the notepad and shows the file which I have filled with clicking the project buttons on this screen. So whenever I click the button Intune, a timestamp and the text Intune is written to this text file, and that's it. And then I can take this later and calculate what I've done. And this is what we've seen is the functions on this screen. Another sample is the button when I have an image. I have defined a button clipboard image open paint.net. When I put an image to the clipboard via the snipping tool, and now I have an image. Clipboard format image. I have an image in the clipboard. And now when I click the button, just a moment, when I click the button clipboard image paint.net, then on my other screen, just a moment, I have too many monitors. Paint.net is opened with the image I have snipped with the snipping tool. This is just another sample. So, and so you can imagine it's quite simple if you have a little bit of knowledge of PowerShell. But when I go further and further with this project, I plan to make a few more samples so that even as a not PowerShell user, you can or someone can define some screens which are useful. And my mouse. So let's go to the last layer and show a few things. On the last layer, I've defined a snipping tool button, a task manager button, and so on. And so when I go to the snipping tool, click the snipping tool, Then slipping tool starts, and I can, where's my snipping tool? Doesn't come up. Snipping tool doesn't start. Well, let's start the task manager. Here's the task manager. Started. This is just a sample. So the usefulness is not so big with the task manager because you can start it from the taskbar, but this was an idea. And so let's come to the last samples of the desktop functions. Starting with Windows 11, maybe earlier, but I use it since Windows 11. There's a possibility to define or to start a new desktop from the taskbar. And can do this, you can close this desktops and so on to move some windows to another desktop. And you can do this via some keyboard functionality, which I can't remember. So I Googled some of these shortcuts and made this layer so that you can start a new desktop, define a new desktop, and show the desktop list with simply clicking this button. And you can close the desktop, can close the other desktop, and you can flip the desktop. Just a moment. New desktop. Clicking back and forth to the next button. And this is simply made by simulating these keystrokes. So that's it. I hope you got a rough idea what can be possible with a few lines of PowerShell code defining such screens and some actions. And what's on this screen? Oh, well, I can I can show you a little bit of the code if you are interested, what's running on the device. Because I told you this is so just a moment. Now I have to reboot this machine. Just a moment. Don't have. Okay. Well, on this device, there's a Micropython script. I don't walk through this Micropython script completely. Just quick scroll through. There's something it's about 300 lines and a few classes which are necessary to better handle the JSON format, which is used to control the layout. And these LV functions, this is what I told you, is the LVGL library, which allows us to create these GUIs. Just a moment. Maybe someone has heard of it. Yeah, that's it. A few examples. And from this button, from this widget sets, I use some button matrix. These are the main functionalities I use for the button for the layers on my device. And there's also the possibility to LVGL Micropython simulator. There's also a Micropython simulator for this, so that you can try out and develop. And there are pages where there are buttons where you can directly switch from these code samples to the simulator and design your GUI. It's not a visual designer, so you have to code something and try it out, but it's really, really helpful to design and try out your user interface with this simulator. And this is what I've done since the start of this year, building this device and the user interface. So for not running out of time, I will say I'll stop here. So we have a few minutes for Q&A if you have some questions.
Yeah, thanks, Frank. So I did have a question. I got a little bit confused about how this device talks to the PC. Like, how do you, what does it actually send? Like, what's the interface?
Yeah, okay. I just a moment. Just a moment. I restart the device. So I'm now running the device without the PowerShell script in the background. But this is the best way I can show you what's happening when the PowerShell script runs. So what you can see now is a problem which I couldn't solve right now. The display in the background should show the user interface right now, because everything in this Python script is done okay. So we are now here. But it takes a few seconds until now to show the user interface. This is something I have to work on, and maybe I have to talk to the support team from Elecrow, where I've bought this device from. I couldn't solve this, but it's okay. If you wait some time, the display, the user interface comes up. So, and what you've seen is I have a few lines of debug code, which are simply some print statements in my code. And so when I press a button, you can see here is a text line sent to the Tony interface, to the Tony integrated development environment. And this is simply done by printing text to the UART device, to the serial port. And when I don't run Tony, but the PowerShell script in the background, the PowerShell script is simply reads from the serial port of the PC. And so this device simply talks via JSON snippets. Each JSON line is a command for the PC backend, which runs in the PowerShell script. And so when I press the button on the first layer, the widget prints green, which is simply the label of the button.
Yeah.
And this is sent as an on-click event because this is prepared for more functionality in the future. So maybe I can implement a bidirectional communication between the PC and the device. As of now, the device only sends commands to the PC, and the PC handles the command simply on the PC. But as you've seen, the LVGL library consists of many, many more layout controls of more widgets. There are sliders, there are drop-down boxes, and so on. Maybe I have some ideas in the future that I can activate more widgets on the device and send back data, maybe the volume state of a loudspeaker or the microphone or something like this, and visualize it on the device. So there's not only on-click. Right now, there is only an on-click device, an on-click event, but maybe in the future I can make a slider event um, to turn up or down a volume or something like this. So this is the communication, just a short line of done one short JSON snippet to the PC, and this is read from the serial port and handled according to what I want to do.
Right. So you could have,
Yeah.
could essentially do anything you want on the PC by PowerShell.
Yep.
So if you had a big network of Windows PCs, you could have buttons for rebooting different PCs and things like that. Is that something PowerShell can do?
Yeah.
Yeah. So I guess if you end up with a big network or something like that, you can see there'd be lots of other uses for it as well.
Yep. Exactly.
That's very
Also
interesting.
this is absolutely, also this is the first project. Yeah, this is the first time I present this project in a user group, and as it fits in the IoT Raspberry Pi ESP32 community, I thought when you asked a few days ago, I can present it here. So it fits in this community, but it even fits in my community where I'm most of the time at home. And so I will present it more with a PowerShell focus in the other user groups. But I thought maybe it's a cool idea. Maybe it's helpful. Maybe someone is interested because the PowerShell part is in the end it will be so simple that if someone wants to use it, even if he's not a PowerShell developer, with a bunch of samples, maybe in a half an hour or an hour, you can design an interface and yeah, what I've said, you get a small productivity gadget because
Cool.
in the end, and this is what I have not shown when where's my PowerShell ISE? It's here. Just a quick last go. Um, snippets. Um, what I have already implemented is an register command, and with this simple one-liner PowerShell, and with such a definition and this simple one line PowerShell command, you can register and schedule task in the user context, so that when you log on as a user to your Windows machine, the scheduled task is started and handles the serial port communication. And so this one line, some definition, and you have a gadget where you can start every command you like, you want from such a small device. And yeah, I think for me, it will become a very cool thing. And if maybe one or two guys also, everything is fine. And as I've mentioned, this project started early in January this year, so it's only yeah, about 10 or 11 weeks in my spare time after work.
Well, there's a couple of questions in the chat as well.
Okay,
Um,
so where's the chat? I stop I stop the screen sharing and then maybe I can see the chat. Well, there's a chat. It's this PowerShell looks nice. It's available for purchase. Well, the Powerdeck, the device is an L-Crow, which I've in the slides. It's about 55 euro. It's an 7-inch human input device, 55 euro from Amazon. So I don't purchase it. You have to buy it on your own. But the software, so the PowerShell module, the firmware, the Micropython-based firmware is from the Electro. And with my scripts, my PowerShell module and the Micropython code, I will publish it on GitHub in the next few days or weeks. And it will become open source. It will become an MIT license. So who want to use it, he can use it. And if someone has questions, then reach out, would be fine. So that's it. Can you put your question in here after? Oh, it's nobody actually could load a graphic to the screen. Yes. What I have implemented on this is simply a proof of concept, when you want to call it like this. Is it possible? What I wanted to do? Yes. With LVGL, you can even put images on the buttons. You can design much more with this. So I plan to allow more functionality on the buttons, symbols. What I have seen, just a moment, I share again. That's a short screen see share. Weg damit. The window. On the window buttons, these left, right, and this X button, these are symbols from the LVGL library. So there's a bunch of about 100 symbols predefined, but these are symbols which you can select via a text. But it's also possible from this library to show images, maybe later. So this was a question about images. Does this require PowerShell 20 or could it be used as a simple HID? Well, the problem with the HID is what I wanted in the first step when I purchased this device, because the ESP-S3 supports HID out of the box, but not this device because the wiring of the device on the back side, if someone this is the wiring, this is the ESP-S3. The functionality to use the HID on this board is not implemented. I don't know why, but it's so. I first purchased another device. It looks similar from the front, but completely different on the back side. It's a WaveShare device. This is a device which I've bought in December. But after starting and experimenting, I found out that the documentation on the website from WaveShare, they stated, well, this board supports Micropython, this board supports LVGL, but unfortunately not together. You can program it with Micropython, but you can't use it with LVGL because WaveShare does not provide a firmware which combines it. And if I want to use it, I had to compile MicroPython with LVGL support for myself. Well, maybe in a few months, or maybe if I can find someone from the MicroPython user group in Australia, who has maybe someone has done it, but is not that what I wanted to do. So I looked out if I find another solution, and so I brought this Electro panel and implemented the human input device functionality on another way, so simply on the PC. So I use Touch Portal to do automation. Yeah, Touch Portal, I've seen it. Touch Portal is the solution where you can use an Android phone, if I remember correctly, to control the functionality on the PC. But if I remember correctly, you have to install a software, a binary on the PC, and communicates via WLAN, Wi-Fi, and I simply wanted to control it via a serial port because in an hardened environment where I work on my job, I cannot connect my working device to a foreign Wi-Fi, but I can communicate via a serial port because the serial port is open because every mobile phone card under the hood works via a serial port in some cases. So you can't block the serial port, and so you can communicate from a PowerShell script in the user context to a device which talks simply serial port. So, cool, thank you. Well, welcome. Yeah. Yeah, okay. Android and so on. The simulator shows Micropython, but the docs offered C code. Where do you find the MP library definitions? There are some. Give me a second. I sent you a link. So LVGL simulator. Just a moment. Yeah, this is a cool sample. Just one sample for device and one last screen share. So you can see the simulator.
Yeah.
Yeah. This is another sample from the LVGL docs, where you can see what's possible, and this is even possible with a device if you implement something. And as I've said, I will publish this in the next days or next few weeks on my GitHub repo, and with documentation and with links to everything I have used for this.
Great.
So I will. I think
Thanks
I
very
can.
much for that.
I can post it on the on the Facebook side of the user group, so everyone who wants has access to this, and with my contact data. So feel free to reach out if you have questions. And I would be happy if someone comes and maybe helps. We'll see.